Okay, we will not wait for them again. Let them join. So in yesterday's lecture, let me share. So what we have discussed yesterday. So the computational complexity compared to the direct computations. Hope you all have understood this.
Yes, sir.
So with this table, we are understanding that why this FFT is much faster than the DFT, because as the n value increases, the computation values are going to be reduced in FFT algorithm, wherein the computation values are increased in DFT. So we can say that FFT is much faster than the DFT. Okay. So now here, like we have taken a few examples, like if n is 8, the FFT is faster than like 5.3 times. If n is 16, the FFT is faster than like 8 times. If n is 1024, then FFT is around 200 times faster than the DFT again. Okay. Now let us discuss next point. You just write title as Radix-2 DIT FFT algorithm. Just write title as Radix-2 DIT FFT algorithm. Radix-2 DIT FFT algorithm. Have you written the title?
Yes, sir.
The title is Radix-2 DIT FFT algorithm. Okay. So first we will discuss how actually it works. मतलब क्या है यहाँ पे Radix-2 is like, as I told you already, the DIT, you just you in bracket you write decimation in time. The full form of DIT is decimation in time. You just write it as decimation in time. Okay. Now, as I mentioned, it is decimation in time. Here, for the time function, we are making a decimation. So what does it mean? Suppose if it is the 8-point sequence we have, right? Then what we are writing here is the sequence length n satisfied that the value should be n equals to 2 to the power L, or it is B, as we have taken yesterday. B as the number of stages required to compute or required to perform the DIT FFT algorithm. Let's see how it works. So first what we are writing is to decompose an n point time domain signal into n signals, each containing a single point. Means what we are doing, like suppose 8 point, we are dividing it into the smaller and smaller part and calculating the final value. The next, each decomposing stage uses an interlaced decomposition, separating the even and odd index. Otherwise, let us understand this. ये एक sequence है आपका, right? So this is a sequence having the value from 0 to 15. So this is in time domain again. So this, what I am doing is I am just separating this into the even numbered part and the odd number part. तो दो sequence में मैंने split कर रहा हूँ इसको. So it is going to be splitted in the two, like even numbered part and odd numbered part. Then further again we are decimating it like this. So even numbered parts को दो part में divide कर रहे. Then for odd number parts also we are dividing it in the two parts again. Right? So this is what the first one we are calling it as n by 2 point DFT, and second one we are calling it as like n by 4 point DFT. Then again further we can write these 4 points into the 2 point, right? Like again this 4 point into 2 point, then 4 point into 2 point, then 4 point into 2 point. So finally what we will write, like 1 value we are writing. So it is again the same as our original value, like it is 0 to 15. So this is what the main meaning behind this DIT FFT algorithm. Are you getting this point? How we are doing the process?
Yes, sir.
रेडिक्स 2 का मतलब क्या है कि यहाँ पे जितना हम उसको छोटा कर सकते हैं, मतलब 2 पॉइंट तक छोटा कर सकते हैं, उससे आगे जा ही नहीं सकते हम, राइट? सो दैट इज व्हाट द मीनिंग ऑफ रेडिक्स 2. It is like the given sequence, we are dividing it into the smaller and smaller part up to the two values. Okay, so this is what the main concept behind this Radix-2 DIT FFT algorithm. So now you note down this point so that you can understand. Just first these points you just note down. And that n equals to 2 to the power v, you write v's or l. The notation may be anything. Are you noting this?
Yes, sir.
Yes, sir.
Or
No, sir. Wait.
can I proceed?
Yes, sir.
Others?
Yes, sir. Completed.
Okay, thank you. In continuation with that, you just add one more line. Let us consider the computation of n equals to 2 to the power b. What you have noted? N equals 2 to the power l or b notation? Hello?
V, sir.
V लिखे है ना, let us continue with V only. So n equals to 2 to the power V, point DFT. N equals to 2 to the power V, point DFT by the divide and conquer approach. By the divide and conquer approach, this selection results in a split of this selection results in a split of the endpoint data. Selection results in a split of the endpoint, that is capital endpoint data sequence, capital endpoint data sequence into 2 n by 2 point data sequence into 2 n by 2, that is capital N by 2 sequence into 2 n by 2 point data sequence x1 of r and x1 of r and x2 of r, x1 of r and x2 of r corresponding to x1 of r and x2 of r corresponding to even numbered and odd numbered samples, even numbered and odd numbered samples of x of n respectively, that is so this part is not required. This is for just understanding purpose I have done it. This already we have written. Just write on this. That is x1 of r equals to, that is x1 of r equals to x of 2r. Call it as equation 1. x2 of r equals to x of 2r plus 1. X of 2r plus 1, where r is equals to 0, 1, 2 up to n by 2 minus 1. Are you getting this point here? So how I have done? Any difficulty here understanding this?
No, sir.
What I have done here, I have just divided the sequence into even numbered part and odd numbered part. Given sequence को हमने क्या किया? Even number, like x1 of r is a even number, x of 2r, and x2 of r is like odd number part, right? Let us call it as equation 1 and 2. And this is a 4 point. Why it is 4 point? Suppose आप n equals to 8 लिए, तो क्या होगा? 8 by 2 minus 1. So 4 minus 1, 3. So 0, 1, 2, 3 तक इसका value present रहेगा. For all other values it is 0. ठीक है? So this is how we are calling it as n by 2 point DFT. So whatever may be the n value. Then next, you just write now. Thus x1 of r and x2 of r. Thus x1 of r and x2 of r are obtained by decimating x of n, decimating x of n by a factor of 2, x of n by a factor of 2, and hence by a factor of 2, and hence the resulting FFT algorithm by a factor of 2, and hence the resulting FFT algorithm is called a decimation in time algorithm, is called a decimation in time. In bracket you write DIT, decimation in time, in bracket you write DIT algorithm, full stop. Finished?
Yes, sir.
Next line. Here x1 of R contain, here x1 of R contain even numbered samples of x of n. Here x1 of R contain even numbered samples of x of n, even numbered samples of x of n, and x2 of R contain, and x2 of R contain odd numbered samples of x of n. Odd numbered samples of x of n. Full stop. The sequence is splitted into two sequences. The sequence is splitted into two sequences. Full stop. Next, we know that the definition of DFT, we know that the definition of DFT is given as, what is the definition of DFT? What is the definition of DFT?
X of k is equal to summation n from 0 to n minus 1 x of n into omega n raised to kn.
Omega n raised to kn. ये अपना definition of DFT है. So for this now we need to divide into even numbered sequence and odd numbered sequence. So let us see this derivation further. यहाँ पे क्या लिखा मैंने अभी? So what I have written here is, so first I have written the definition of DFT. So this is what the part we are having, the definition of DFT. Okay. So what I have done then, I have divided this into the even numbered sequence and the odd numbered sequence. Getting my point? Yes or no?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So then in the first summation value, I'm just substituting the value of this x of n as x of 2r. Okay, already we have decided this x of n is like x of 2r for 1 point, and again x of n is for the x of 2r plus 1. That means we are dividing this function into the even number sequence and the odd number sequence. And this is for the 4-point value we are writing. So x of 2r के लिए हमने क्या लिखे थे? x1 of r बोल के लिखे थे. Right? So please write down this derivation. You may expect this as a theory question again. They will ask you like derive an expression for Radix-2 DIT FFT algorithm. If you are not understanding, simple simplification we are doing here, nothing new in that part. So if you are not getting any point, you just ask me. So if anyone is having the doubt here, please ask. If you are not understanding at any point. Finished? Have you finished this part?
Yes, sir.
So any confusion, any question here?
सर लास्ट सेकंड स्टेप मध्ये W n/2 घेतले ते n/2 कसं घेतलंय?
W?
n/2
So this part, na?
raised to
Okay.
RK.
Okay.
हाँ,
Let
yes.
me tell you that part. That is very important question again. Okay. So what is the question is like how we have written this part, na? So it is Wn to the power 2rk is there. Okay. So that can be written as Wrk as a n/2 part. Okay. So how we can write this as? So here Wn to the power Wn to the power 2rk is there, right? So this can be written as Wn/2 to the power rk. So this is the question. कैसा लिखा बोल रहा है ना ये?
Yes, sir.
Okay. So now, as we know that Wn can be written as, how we are writing this? E power minus j 2 pi by n. बराबर? Yes or no?
Yes, sir.
Now, this
हाँ, sir.
Wn to the power 2rk can be written as e power minus j 2 pi rk divided by, it is 2 again, by n. बराबर?
Yes,
Yes or
sir.
no? मतलब, or else this can be written as simply this is equals to e power minus j 2 pi rk divided by n/2 लिख सकते हैं हम इसको. Yes or no?
Yes, sir. Yes, sir.
Right. So this can be written as, so simply this is again is equals to, now if you look at into this part, this can be written as w, this can be written as like rk divided by n/2, it is like this. So that is the main part. Understood? So this is this simply this is for the value of 8 point we are writing, और ये वैल्यू आपका 4 पॉइंट के लिए हम लिख रहे हैं. Getting my point? So this is for 8 point we are writing. This is for 8 point we are writing, and this is for the 4 point we are writing. ठीक है? So that is the meaning here. Now let's move further. Any still question? तो ये वैल्यू समझ में आएगा कैसा आ रहा बोल के? WNK. Getting this?
हाँ सर.
क्योंकि यहाँ पे मल्टीप्लाई करने के बाद लाइक WN 2RK, इसके लिए ये वैल्यू लिखे WRK by N by 2, and WNK is there. I have taken it outside. So we got it as x1 of k plus Wn to the power k x2 of k. Okay. Now let's move to the further. So that is, then just write this part. So x of k equals to x1 of k plus Wn to the power k x2 of k for k equals to 0, 1 up to n by 2 minus 1. Then by applying a symmetry property, we just add one line there. You please give that number also, equation number. क्या नंबर दे रहे हैं आप? x of k equals to x1 of k plus Wn to the power k x2 of k. इसके लिए नंबर 3 देंगे. What is the number you are giving? 1, 2
Yes,
दिया है
sir,
ना?
3.
1, 2 we have given already, right? So let us give a 3 for this. This is equation 3 again. Now you just after equation 3 we just write 1 point. So this is our equation 3. Okay. So after this we will write using symmetry property of a twiddle factor. Using symmetry property of a twiddle factor, we can write it as, we can write, if you replace k by the value k plus n by 2. So as we have seen already, क्या हुआ था value वहां पे? What is the statement? Can anyone tell me? What is the statement of symmetry property of a twiddle factor?
Wn to the power k plus n by 2 is equal to minus Wn to the power k.
Okay, so using that we are writing this. Simply I have replaced k as a k plus n by 2 value, which will be equals to x1 of k plus n by 2 plus Wn to the power k, again I have replaced it by the value k plus n by 2 multiplied with x2 of k plus n by 2. Therefore we can write finally x1 of k equals to minus Wn to the power k x2 of k. We call it as equation 4. Call it as equation 4. Understood?
Yes, sir.
So now this is what the simplest way how we have done, right? तो हमने क्या किया यहाँ पे? तो पहले x of n को we have splitted it in x1 of r and x2 of r. बराबर? What is x1 of r here? x1 of r stands for even numbered sequence and x2 of r stands for the odd numbered sequence. Correct? Yes,
Yes,
or no?
sir.
You just note down that, like you just take this diagram to understand easily again. So this x of n is splitted into the even numbered sequence and the odd number sequence. So that is x1 of r and x2 of r. Then by taking its DFT, we are writing as x1 of k and x2 of k. And by further adding these two sequences, we'll get the value of x of k. Further adding these DFTs, we will get the value of x of k. So what you are understanding with this diagram? What is the conclusion out of this? Yes, anybody please? What is the conclusion out of this? कुछ तो बताओ.
For calculating DIT FFT algorithm, first we have to split the given sequence into even numbered and odd numbered sequences and
Okay.
calculate its DFT and then add both the DFTs.
Okay, so मतलब क्या है कि simply we are converting again a time domain sequence to the frequency domain sequence. Getting my point? So that is what again the main purpose we are doing here with this FFT algorithm again. Okay, we are converting a time domain sequence to the frequency domain sequence. So this is what we are calling. This is a 4-point DFT हुआ अभी, इसको हम 2-point DFT में भी convert कर सकते हैं, right? So let us understand the flow diagram here. Butterfly computation flow diagram for this. Just note down these equations. Equation 3 and 4 already are noted. The butterfly diagram क्या है अभी आपका? So this already I have shown you the diagram. तो यहाँ पे इनपुट क्या रहेगा आपका? x1 of k and x2 of k will be the input. Okay. Just take that butterfly diagram here. Butterfly diagram or butterfly computation flow graph. You can write. So what will be the output at the first part? Can anyone tell me? Hmm? Anybody? तो आउटपुट क्या आएगा एट द फर्स्ट पॉइंट यहाँ पे? So what will be the output at this point?
x1 of k plus wn raised to k into x2 of k.
This is first equation. बराबर? So we are getting the first equation here, right? So x1 of k plus w into the power k, x2 of k. So this is the way how we are calculating the output function. Then at the second point, क्या आउटपुट आएगा? Anybody?
Instead of plus there is minus.
Instead of plus there is minus because क्यों माइनस है वहां पे? So here this complete sign is multiplied with or this complete line ये जो दिख रहा है यहाँ पे आपको multiplied with the -1. तो यहाँ पे ये line multiplied by -1 है. So for that purpose we are getting this as a minus. So x1 of k minus w into the power k x2 of k. So this is how we are calculating our result using this butterfly diagram. Understood?
Yes, sir.
Any confusion here?
No, sir.
Now, so let us calculate it for 8 point के लिए butterfly diagram क्या रहता है, right? So this is how the first sequence like 8 point we have taken. 8 point के लिए क्या किया हमने? We have divided the given sequence into the even numbered part and the odd numbered part. Getting my point? लिख लो ये लोग सभी. You just write that like continuation is butterfly diagram for 8 point, n equals to 8 point. Butterfly diagram for n equals to 8 point. x1 of 0, x1 of 1, x1 of 2, x1 of 3, x1 of 0, x1 of 1, x2 of 0, x2 of 1, x2 of 2, and x2 of 3. डायग्राम थोड़ा बड़ा आएगा. आई थिंक यू नीड राइट इट प्रॉपरली. Just start with the left corner. Finished?
Yes, sir.
This is our first step. The next step, what we are doing, as I told you already, x1 of r is even number, x2 of r is the odd number, right? तो अभी ये n by 2 point DFT हम बोल रहे हैं इसको, and then again second one is the n by 2 point DFT, right? So what is the output at this point? x1 of 0, x1 of 1, x1 of 2 और x1 of 3. मतलब ये जो वैल्यूज है यहाँ पे हम इसके DFT लेने के बाद x1 of 0 का DFT क्या आएगा? कैपिटल x1 of 0. x1 of 1 का DFT कैपिटल x1 of 1. The output will be as a DFT we are getting. Similarly for this part. ठीक है? Just take this. Hope you are understanding this.
Yes, sir.
Just draw this diagram. Or
Yes, sir.
so any confusion here? With the help of n by 2 point DFT, I have calculated the DFTs of this thing. Okay. Now, अभी मुझे यहाँ पे आउटपुट कैलकुलेट करना है. Like x1 of 0 आउटपुट I wanted to calculate. Sorry, x of 0. तो कोई बताएंगे मुझे आंसर अभी? Which line I need to add? If I want to calculate x of 0 value. So what are the points to be added? Anybody?
x1 of 0 plus x2 of 0 into wn to the power 0.
Very good, right? So let's see this. ये अभी x of 0 कैलकुलेट कर रहा हूं मैं. Getting my point?
Yes, sir.
Anybody having any confusion here? Please try to understand because we are solving the examples with this diagram. यहाँ पे कोई कंफ्यूजन है आप लोगों को?
No, sir.
No, sir.
पक्का? Can I move
No,
further?
sir.
Now
Yes,
next.
sir.
Suppose if I want to calculate x of 1 value. Now who will tell me the answer? What the points to be added? x of 1 का वैल्यू मुझे कैलकुलेट करना है अभी.
x1 of 1 plus x2 of 1 into wn to the power 1.
Very good. Right. Sorry. Like वो ठीक है लेता हूं मैं. Then x of 4 अभी एक मतलब ये एक सैंपल पूरा डायग्राम कंप्लीट कर रहे हैं यहाँ पे. तो x of 4 के लिए क्या what he has taken is x1 of 0 minus 1 wn 0 x2 of 0. ठीक है. So likewise he is adding all the values. अभी x of 1 के लिए आ गया. ठीक है. x of 1 plus x2 of 1 wn to the power 1. The next x of 5 x of 5 के लिए क्या आएगा? कंफ्यूज हो रहा है? हेलो हेलो, am I audible?
Yes, sir.
Then what will be the addition for x of 5?
x1 of 1 minus x2 of 1 into wn raised to 1.
Okay, तो ये x of 5 आ गया आपका, right? So likewise we need to combine all the diagram. So this is the way how we are calculating the final value. Have you understood this?
Yes, sir.
This is one stage computation we are calling. But if it is a 8 point, we require a 3 stage computation. As I told you yesterday, this is one stage computation. Just complete this. Take down this diagram. So please be careful for the location of multiplier, that is wn0, wn1, wn2, wn3. So we have to be very careful and note down that like where is the minus sign also. So here we have the minus sign at this point. So this is where the minus sign we are having. So like if you want, you can write it like this also, so that you can understand. So this is the -1 for this line. तो ये -1 है, दिख रहा है -1 है बोल के, येलो है उसकी वजह से नहीं दिख रहा है शायद. दिस इज -1. तो अभी आप लोगों को पता ही है, लाइक इन इक्वेशन what's going to happen here, first 4 values are going to get by adding the 2 DFTs and multiplied in second DFT is multiplied with the multiplier wn0, wn1, wn2, wn3, and the next 4 values will be calculated by subtracting the values, and the second DFT is multiplied with the again multiplier. मतलब 4 बार एडिशन आएगा और 4 बार सब्सट्रैक्शन आएगा यहाँ पे. और
Yes, sir.
any confusion here?
No, sir.
My question to others also. बाकी लोग भी है वहां पे. बाकी लोग है क्या नहीं वहां पे? हेलो.
Yes, sir.
बाकींचं काय आवाजच येत नाही बाबा.
Yes, sir.
नसीब माझा, अजून थोडं थोडं आवाज यायला लागले. हा. एवढं सायलेंट कधीपासून झाला मॅडम? Boys, anyone is there from boys side?
Yes, sir.
वाह 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 वाह, ग्रेट. अरे बाबांनो, बाकीने बी जरा आवाज द्या की मला, छान वाटतंय जरा. राईट. एनी डिफिकल्टी? कळालं का इथं काय कन्फ्युजन? आता सगळेच बंद झाले. आणि
सर, एक्सक्यूज मी सर.
हा,
सर अजून एकदा एक्सप्लेन करा की.
कुठं कुठं कळालं नाही मॅडम तुम्हाला? विच स्टेप यू आर नॉट अंडरस्टूड? लास्ट वाला
ते
या
arrow वाला कळलं नाही सर.
एड वाला, एरो वाला, लास्ट वन. ओके, देखो सिंपल है यहाँ पे. तो फर्स्ट हम टू कैलकुलेट द वैल्यू ऑफ दिस x ऑफ 0, अपना बटरफ्लाई डायग्राम क्या है? लेट मी टेल यू इन दिस वे अदरवाइज. राइट. सो हमें अभी ये बटरफ्लाई डायग्राम है अपना. राइट. सो हियर, सो व्हाट आई वांट, दिस इज सिंपल बटरफ्लाई डायग्राम. राइट. ये अपना बटरफ्लाई डायग्राम है. ठीक है. एज वी हैव सीन ऑलरेडी, अभी मुझे यहाँ पे x ऑफ 0 का वैल्यू कैलकुलेट करना है आपका. सो x ऑफ 0 इज इक्वल्स टू, तो यहाँ पे अगर आप डायग्राम देखेंगे, सो हाउ इट इज लुकिंग, x1 ऑफ 0 is added with the value x2 of 0. Right. x1 of 0 is added with the value, this is x1 of 0 plus omega n to the power 0 x2 of 0. ये दोनों वैल्यू एडेड है वहां पे. सो दैट मीन्स, सो हाउ इट इज गोइंग टू बी ड्रॉन, तो ये हो गया आपका. ठीक है. मतलब ये फंक्शन और ये फंक्शन दोनों ऐड किया हम यहाँ पे. इट इज लाइक x1 of 0 and this is x2 of 0. आला लक्षात मॅडम आता?
Yes, sir.
So likewise we are
Yes,
doing
sir.
the addition of all the values. ठीक है. So that is, so this is first value. Likewise, पहले ये आपको कंफ्यूज हो रहा है तो ये पहला 4 ऐड कर लो. राइट. सो देन अगेन, सो यू जस्ट सब्सट्रैक्ट दिस. Likewise you can do this part. सिंपल बटरफ्लाई डायग्राम लक्षात ठेवायचं आपलं. देन we have to do the simple procedure like 4 times we are adding the sequence and the 4 times we are subtracting the sequence. This is one stage value. Still anybody is having question?
No, sir.
No, sir.
Can I move further?
Yes, sir.
Yes, sir.
ओके नाउ अभी ये अपना कंप्लीट डायग्राम है. कल अपने हमने देखे लाइक नंबर ऑफ स्टेजेस रिक्वायर्ड टू कंप्यूट 8 पॉइंट डीएफटी. कितने स्टेजेस चाहिए हमें? 3 स्टेजेस वे रिक्वायर. ठीक है, तो उसके लिए हम नंबर ऑफ बटरफ्लाईज कितने चाहिए वो सब देखे हैं वहां पे. ठीक है, सो हियर दिस इज व्हाट द फाइनल डायग्राम. ये अपना पहला स्टेज है. फर्स्ट आई हैव कन्वर्टेड द गिवन सीक्वेंस इनटू ये इवन नंबर एंड इवन नंबर सीक्वेंस है और ऑड नंबर सीक्वेंस है. देन द सेकेंड स्टेज इज लाइक दिस. This is a 2 point, this is 4 point, and finally it is 8 point value. So this way you will get the answer. ये अपना फाइनल डायग्राम है अभी. So this is the way how we are calculating the 8 point DIT FFT by using this algorithm. ड्रॉ करेंगे इसको.
हाँ, sir.
और कैन आई कीप द स्टेज वाइज? फर्स्ट कंप्लीट दिस. ज्यादा देख के डर जाएंगे नहीं तो आप लोग. हो गया फर्स्ट स्टेज.
नहीं, sir.
Can anyone tell me what number of DFTs it is? कितना पॉइंट DFT बोल रहे हैं हम यहाँ पे इसको? So what is the DFT size here? हुआ क्या? Hello?
Completed.
Completed. Okay. So what is the DFT size? कोई बताएंगे मुझे?
8.
No, no. One diagram कितने पॉइंट का है? Total is 8 point it is. Now अभी like one diagram is of which point? How many points? किती इनपुट आहेत आणि किती आउटपुट आहेत त्याला? पहला मतलब फर्स्ट डायग्राम, फर्स्ट बटरफ्लाई डायग्राम के लिए how many inputs are there and how many outputs are there?
Two.
Yes, वहां पे एक बटरफ्लाई डायग्राम के लिए, पहला डायग्राम के लिए x ऑफ 0 इनपुट है और x ऑफ 4 इनपुट है, ठीक है? तो कितने इनपुट हो गए अभी इसका यहाँ पे? 2-point DFT. So this stage we are calling it as a 2-point DFT. Then next we are calling it as कितने point? 4-point DFT. And finally we are coming to the 8-point DFT. So this is the diagram. Can I stop it here? We will proceed further again in tomorrow's lecture.
Yes, sir.
Thank you, madam. इसके लिए तो yes sir बोले. Please start marking your attendance. So we will start again by the tomorrow lecture with this diagram only, and we will finish this part, and then we will start some examples on this. Shall I close here?
Yes.
Yes, sir.
Okay, thank you.